Imagine launching a spaceship to Mars in just days instead of months. Sounds like sci-fi, right? Well, buckle up because we're diving into an incredible idea. Elon Musk has long championed the idea of making humanity a multi-planet species, but current propulsion technologies limit how quickly and efficiently we can send payloads into deep space. Today, we send spacecraft to space using chemical rockets, like giant firecrackers. They burn tons of fuel to reach speeds of about 40,000 kilometers per hour. That's fast, but it still takes 6 to 9 months to get to Mars. Why? Rockets need to carry all their fuel, which makes them heavy and limits their speed. This is why we need to find ever more inventive and creative propulsion solutions. Now, picture a totally different way to launch. A 10,000-kilometer-long railgun built around the moon's equator. A railgun is like a giant electromagnetic slingshot. It uses powerful magnets to shoot a spacecraft at insane speeds, without burning a drop of fuel. To make this railgun ultra-efficient, we add magnetic levitation, or maglev, like those super smooth, high-speed trains that float above their tracks. This lets the spacecraft glide without touching the rails, wiping out friction and heat. And here's where it gets really cool. The railgun is built with graphene, a material so strong it makes steel look like paper. How do we power this beast? With massive solar panels on the moon, tapping the sun, the biggest fusion reactor in our solar system. These panels soak up sunlight to generate billions of watts, enough to launch spacecraft at 1.9 million kilometers per hour for robots, 50 times faster than rockets. For humans, we ease it to 120,000 kilometers per hour for comfort. But all that power creates heat, so we need to keep things cool. Enter liquid hydrogen, the same stuff used as rocket fuel. At a chilly minus 253 degrees Celsius, it's perfect for cooling our railgun's magnets and rails. By repurposing rocket fuel, we save space and make the system super efficient. No extra coolant needed. Plus, in the moon's near vacuum, this cooling keeps everything running smoothly without overheating. So, how fast can this graphene-powered, hydrogen-cooled railgun go? For a robot spacecraft, it could blast off at 1.9 million kilometers per hour, 50 times faster than a rocket. For humans, we keep it gentler at 120,000 kilometers per hour to avoid turning astronauts into pancakes. Either way, it's a game changer. Let's talk Mars, about 225 million kilometers away. Chemical rockets take 6 to 9 months to get there. But our lunar railgun, a robot spacecraft, could arrive in just 5 days. For humans, it's about 79 days, still way faster than today's rockets. Want to go even faster? We're doubling up with mirrors on the spacecraft and the moon. The spacecraft unfurls a giant super light solar sail, like a space kite, coated with dielectric mirrors that reflect nearly all light. At the same time, huge mirrors on the moon bounce sunlight or laser beams at the sail, giving it an extra push right after launch. Here's how it works. The lunar mirrors blast light at the sail for about a day, giving a big speed boost. Then the sail keeps catching sunlight the whole trip to Mars, pushing it faster and faster. For humans, this combo could cut the journey to just 40 days. The robot spacecraft is already so fast it still takes about 5 days, but the extra kick makes it even more efficient. Building this railgun and mirror system on the moon is a massive challenge. It needs crazy power, like 100 nuclear plants for the robot version, and high-tech gear like graphene, hydrogen cooling, and giant mirrors. But the payoff? A reusable, ultra-tough setup that could make Mars feel like a quick trip next door. But how do we pay for this mega project? By mining the moon's far-side craters? These craters, like the giant South Pole Aitken Basin, are packed with treasures from ancient meteor strikes. Think water ice for fuel, rare metals like platinum, and even tiny diamonds. Mining just one crater could bring in billions of dollars by selling water and metals for space bases or fuel stations. That cash could build and run our railgun, making Mars trips a reality. But here's the wild part. Railgun-launched robots can mine asteroids for billions in metals and water, fueling space bases and Earth's tech. Even crazier? We could redirect asteroids to crash into Mars, carrying water or gases to thicken its atmosphere, making it warmer and more livable, like adding air to a thin balloon. Some asteroids might even carry radioactive materials to heat the planet, jump-starting a new Mars. So, what do you think? Could this lunar super railgun and solar sail be our ticket to exploring the solar system? Let us know in the comments, and don't forget to like and subscribe for more out-of-this-world ideas.